Hello students, today we will be starting a new chapter which is quite an important chapter because a 4-mark question always comes from this chapter and some other questions as well, which is, as you can see, surface areas and volumes. Now you have already dealt with this chapter in class 9 where we had our cubes and our cuboids and certain other shapes that might have been taught depending on your school. This year we will be continuing with those, adding new figures as well as dealing with situations where we have a combination of figures. So it won't just be a straightforward case where it's just a cube or a cone or a cylinder. There will be combinations. You will need to deal with them intelligently and then understand how to proceed with the question. So the figures we'll be dealing with this year are of course your cube and cuboid. You have your cone, cylinder and sphere along with hemisphere, which is nothing but half of a sphere, and a new shape known as a frustum, which is nothing but a cone that is cut parallel to the base, sort of like a cup that's smaller at the bottom but bigger at the top. Now we will deal with the cone frustum later. Let's deal with the other 5 shapes first and then come to the frustum at the end of the chapter. So before we do anything in surface areas and volumes, we always like to have our formulas. So let's do a quick recap of the formulas which you remember and the new formulas which we'll deal with. Starting with, of course, our most basic one, which is our cube. Now, we know that our cube is nothing but a figure like this, a box which has a length of s, a breadth of s and a height of s. And so the volume is equal to s cubed, s into s into s, and the total surface area is equal to 6 s square, because the cube has 6 faces, each of which is a square of side s. So 6 times the area of the square, s square. Total surface area always means all 6 faces. Like I said, this year you'll have to use your own intelligence to figure out how many faces do you need and will you use. Now, after cube, we have the related shape, which is our cuboid. And if a cube is just an extension of a square, a cuboid is just an extension of a rectangle. And so in our cuboid, our 3 major dimensions are the length, which is traditionally considered as the longest side, but not necessarily. The breadth, which is always connected with the length, usually making the base of the figure, and the height of the cuboid. And so once again, the volume of the cuboid is length into breadth into height, or simply LBH. The total surface area is equal to 2 times, in brackets, LB plus BH plus LH. Because the logic is that we have 2 faces that are the rectangle made by the length and the breadth. So length into breadth would be their areas. There are 2 of them. So 2LB. Similarly, the face with the breadth and the height. BH, 2 of them, 2BH. Then also the front face, which is made up of the length and the height. So 2LH. And so when we add them together, we take common and this is what we get. So these are our 2 polygonal shapes that have edges, vertices and things like that. Let's now move on to the first non-polygonal shape, and let's start with a simple sphere. Now of course a sphere is nothing but a three-dimensional circle. And if we want to make a three-dimensional circle, normally illustrating it is a bit challenging, so we simply take a circle. We assume that this is three-dimensional, and the beauty of the sphere is that it simply has, like the cube, only one determining parameter, which is the radius r. Now, the volume of the sphere is equal to 4 by 3 pi r cubed. The curved surface area or total surface area, because in a sphere there is only one face, so the surface area of the sphere is 4 pi r squared. Now, there are derivations for these formulas, but they are very high level concepts, things that you don't even learn in class 11 and 12, things you learn in college if you take maths. So we're not going to be doing any of that. You just need to remember that a sphere has a radius, the volume is 4 by 3 pi r cubed, the surface area is 4 pi r square. Now, after the sphere, we have the cylinder. Now, a cylinder is basically like a bottle or a pipe, right? And so in our cylinder, we have a couple of determining parameters, starting with, as usual, it is a circle at the bottom, so it will have a radius of r, and clearly it has a particular height, so a height of h. So a cylinder is defined by its radius and height. Now, the volume of a cylinder is equal to pi r square h, because the idea is that I start off with my base, which is pi r square, and I drag it for my height h. So pi r square h. Now, unlike the previous three figures, we will define two types of surface areas for the cylinder. Starting with CSA, which is known as the curved surface area. Sometimes it's also known as the LSA, or the lateral surface area. Now, the curved surface area or the lateral surface area of a cylinder is 2 pi r h. They are basically talking about the round part of the cylinder, the outer wall of your bottle. And so it's obviously nothing but the circumference of the circle, 2 pi r, dragged along the height h. So 2 pi r h. The total surface area of a cylinder is normally taken as the curved surface area plus the base as well as the top, which would be 2 pi r h plus 2 pi r square, because obviously the base will be pi r square and the top will be pi r square. We can simplify this to 2 pi r into h plus r as a simplified formula. So, cylinder, radius and height, volume pi r square h, curved surface area or lateral surface area 2 pi r h, and total surface area 2 pi r bracket h plus r. Let's move on to a cone. Now, the thing about a cone is that it is, the formulas of the cone are related to the formulas of the cylinder. Now, the cone will have your radius again. Your cone has a height, and your cone has a third dimension which you can see here, known as the L, or the lateral length, the slant height. L is known as the slant height. Its use comes in surface area. Now first we can see that the slant height L will be equal to under root h square plus r square, because clearly h is perpendicular to r and therefore this is nothing but a right angle triangle. So L is root h square plus r square. Now the volume of the cone, like I said, is related to the volume of the cylinder. It is 1 by 3 pi r square h. So 1/3 the volume of the cylinder. This again has a big derivation like the sphere. It's not something straightforward like the cylinder, which is just dragging of your base. So we will not be dealing with that. The cone also has a curved surface area or a lateral surface area like the cylinder. This is where your slant height will be used. It is equal to pi r L. So simple, pi into your radius into your slant height. And the total surface area. Now for a cone, obviously the top is just a point. It has no area. The bottom will contribute. So it will be pi r L plus pi r square, which can again be simplified to pi r into L plus r. So cone. And then finally, although technically you can derive these for yourself, let's also look at a hemisphere. Now a hemisphere is literally nothing but half of a sphere. So imagine you take a sphere and cut it in half. So if you've ever seen a cricket ball is actually made up of two hemispheres that are glued together and then stitched together. So if you ever see a cricket ball break in half, one side is a hemisphere. Now, the thing about the hemisphere is that logically, if you think about it, the volume of the hemisphere, again it has a radius of r, is nothing but half the volume of the sphere, since we said it's half of a sphere. So it would be half into 4 by 3 pi r cubed, which is nothing but 2 by 3 pi r cubed. Now the hemisphere will also have a curved surface area and a total surface area. The logic of the curved surface area is the same as the logic of the volume. The curved part of the hemisphere is literally half the curved part of the sphere, but the curved part of the sphere is just the total area of the sphere. So it will again be half into the curved surface area of the sphere, which is 4 pi r square or 2 pi r square. And so if you need to get the total surface area of your hemisphere, it would be equal to nothing but, once again, the curved surface area plus the flat surface area, which here is just the circular portion. So 2 pi r square plus pi r square, which is nothing but 3 pi r square. And so these are our 6 basic shapes and their volumes and surface areas. So let's get into questions where we are dealing with these values, and we're going to jump straight into questions that not are too complicated but make you think about what is the combination of shapes and what is it that I have to do. So let's look at that.